Hello everybody. Now in this lecture we are going to see the determination of boric acid by titrimetry and determination of sodium benzoate by HPLC technique. Okay, so first we will see the determination of boric acid by titrimetry. As we know that boric acid is most commonly used as a preservative. Okay, so exposure to large amount of boric acid can affect the brain, liver, stomach, bowel, and kidneys also. Okay, so boric acid can be determined by volumetric method, but the result may have considerable error if the foodstuff contain large proportion of the fat or the phosphate and other ingredients. Okay, so we will see the principle here. So remember, we are doing the analysis of boric acid by titrimetry and sodium benzoate by HPLC. So boric acid react neutral to the methyl orange, but as acid with the phenolphthalein. Neutral with the methyl orange means their pH is almost the same. The pH range in which methyl orange is active, in that pH range only the boric acid is having its pH, or the in case of phenolphthalein, it acts as an acid. Means phenolphthalein is active in a pH range, and that would be the basic compared to the boric acid pH. Okay, so it can be quantitatively titrated in presence of polyhydroxy carbonates, the compounds, polyhydroxy compounds such as glycerol or mannitol, which prevent the hydrolysis of sodium borate. The alkali present is first neutralized in presence of methyl orange. The alkali present is first neutralized in presence of methyl orange, and the liberated boric acid is titrated against the sodium hydroxide using phenolphthalein as an indicator. पहिले जे अल्कली आहे त्या न्यूट्रलाइज कुठे करतोय मिथिल ऑरेंजच्या प्रेझेन्स मध्ये, आणि जो बोरिक ऍसिड लिबरेट होणार असेल तो आपण NaOH आणि phenolphthalein इंडिकेटरच्या साहाय्याने डिटेक्ट करणार आहोत. ओके, सो the method is applicable to starch products and dextrin. Starch product and dextrin. So here what reagents are there? 0.1 normal NaOH, 0.1 normal H2SO4, mannitol is there, methyl orange indicator, phenolphthalein indicator. So what is the procedure? Take 1 gram of sample, transfer it to 250 ml of beaker, then add 100 ml of distilled water and heat that to the 90 degrees Celsius continuously. Titrate that hot solution against a 0.1 normal H2SO4 solution in presence of methyl orange indicator. End point will be the orange red, orange to red. Okay, so this is what your end point. After you are getting the end point, now here your alkalis are get neutralized. Now you are proceeding for detection of boric acid. So add phenolphthalein indicator in that and titrate the solution against 0.1 normal NaOH. You will get the pink. Okay, then add again to this 1 gram of mannitol solution. If pink color disappear, continue the titration. Again pink color reappears. What happens? You have to continue. See, I'm going through the sentence. Okay, again add 1 gram of mannitol and titrate to titrate to a pink end point. Continue the process until addition of mannitol does not changes the pink color of the solution. Okay, हे कुठपर्यंत करायचं आहे की मॅनिटॉलची ऍडिशन केली काय होतं की पिंक कलर डिसअपियर होतो. हे कुठपर्यंत करायचं आपल्याला मॅनिटॉल आपण टाकत राहणार आहे आणि पुन्हा टायट्रेशन करत राहणार आहे जोपर्यंत पिंक कलर परसिस्ट होत नाही, तो तसाच राहायला पाहिजे. आता मॅनिटॉल टाकले मी, पिंक कलर गेला नाही तर तो एंड पॉइंट असेल, पण मी मॅनिटॉल टाकला आणि पिंक कलर गेला तर आय हॅव टू कंटिन्यू द टायट्रेशन. Getting my point? So in this way we can get the end point. So the 1 ml of sodium hydroxide is equal to 0.0031 gram of boric acid. मग किती ml आपल्याला NaOH त्या ठिकाणी लागला च्या बेसवरती आपण किती बोरिक ऍसिड त्याच्यामध्ये प्रेझेंट आहे ते कॅल्क्युलेट करू. this is what the reaction S3BO3 with the NaOH gives you S2BO3 minus Na plus and S2. Okay, electrochemically सुद्धा आपण त्या ठिकाणी डिटेक्ट करू शकतो, but here as we are studying titrametrically, so no need to go for the further process. That is enough what we have learned using methyl orange and phenolphthalein. Second is the determination of sodium benzoate with the help of HPLC. Okay, so it is used as a preservative in pharmaceutical and food industry. So it is estimated by titrametry as per the procedure given in British Pharmacopoeia and the Indian Pharmacopoeia. Assay of sodium benzoate can be carried out by HPLC with isocratic elution using mixture of buffer and methanol and water. Okay, त्याच्यामध्ये बफर असणार आहे, त्याचं मिक्सचर कशाबरोबर मिथाल आणि वॉटर in the ratio of 60:40 using C18 column. Flow rate of 1 centimeter cube within 10 minutes and detected at the wavelength of 254 nanometer. So the reagent, chemical and instruments. We are using their methanol, potassium dihydrogen orthophosphate, triethylamine, orthophosphoric acid, deionized water, HPLC system consisting of C18 column, pump, UV detector. Okay, so chromatographic condition, flow rate हा 1 ml per minute मेंटेन करायचा आहे. जे आपण अगोदर शिकलो ना जीसी मध्ये, त्या पद्धतीने HPLC असतो. आणि HPLC मला वाटतं त्या ठिकाणी that is also very familiar to you, that I have already explained to you. Then the detection is carried out at 254 nanometer. Sample volume will be 20 microliter while injecting into the system. Run time will be 10 minutes. Okay, so the buffer, we have to prepare buffer first, and then we have to prepare the mobile phase. Then we are preparing the standard, and then we are preparing the sample solution. So buffer dissolve 6.8 gram of potassium dihydrogen orthophosphate in 1 liter of water. Add 1 ml of trimethylamine. Adjust the pH from 5.5 plus minus 0.1 with the orthophosphoric acid. Filter it through the 0.45 micron nylon membrane filter paper. Degas it with the ultrasonic bath for the 5 to 10 minutes. In the mobile phase, mix the buffer and methanol in the ratio of S2:40 and degas with the help of ultrasonic bath. That is the process used for the degassing. In the standard preparation, take a 20 milligram of sodium benzoate and transfer it to 20 ml of volumetric flask. Add 150 ml of mobile phase and sonicate this to remove the gas. Okay, so pipette out 25 ml of the solution in 100 ml of volumetric flask and dilute the solution with the mobile phase. Okay, now for the sample preparation, take 20 mg of sodium benzoate, transfer it into the 20 ml of volumetric flask, add 150 ml of mobile phase, sonicate, make up the volume with the mobile phase. Okay, and pipette out 20 ml of solution into 100 ml of volumetric flask and dilute to the volume with the mobile phase. Okay, so by dilution we have to pass both standard and the sample solution from the column. So procedure for injection, separately inject 20 microliter of blank, जे की स्टँडर्ड ब्लँक ज्याच्यामध्ये बोरिक ऍसिड नसणार आहे. स्टँडर्ड प्रिपरेशन and the sample preparation. पहिला हा ब्लँक पास करा, नंतर स्टँडर्ड पास करा आणि नंतर सॅम्पल पास करा. ओके, so and let the chromatography record the chromatogram. So we are going to measure the response over there, and if we will get the peak with the retention time 4.1, so that indicates the presence of boric acid is there in the sample. Okay, and how that peak we come to know that will be at the 4.1 retention time, because before running the sample we are running the standard from the HPLC column. Okay, and the standard will give the peak at 4.1. Hence, if we get the same peak from the sample, then we come to know, yeah, की स्टँडर्ड मध्ये जर ही पीक आली होती ज्याच्यामध्ये आपण बोरिक ऍसिड घेतलं होतं, तर सॅम्पल सुद्धा जर ही पीक देतोय तर डेफिनेटली त्या ठिकाणी त्यामध्ये बोरिक ऍसिड प्रेझेंट आहे. ओके, अशा पद्धतीने ते आपण करणार आहोत. ओके, सो इन द नेक्स्ट लेक्चर आय एम गोइंग टू कंटिन्यू विथ द मिल्क. ओके, सो स्टडी अँड अनालिसिस ऑफ फूड प्रोडक्ट्स अँड डिटेक्शन ऑफ अडल्ट्रंट. त्याच्यामध्ये कुठले अडल्ट्रंट असतील त्याचा आपण त्या ठिकाणी स्टडी करणार आहोत. इन दिस लेक्चर वी हॅव स्टडीड how to determine the boric acid and sodium benzoate. Okay, sodium benzoate, boric acid by titrimetry, and sodium benzoate by HPLC technique. Okay, thank you. Remaining I will continue in the next lecture.